Welcome to Weaviate Vector Database Introduction Tutorial. We will first see what vector database is all about. We do have various types of data like text, images, audio files, and video files. And doing a full text search on these based on either the existing NoSQL data models or on the relational data models is found to be challenging. And this is where actually vector databases come into picture. In vector databases, we store what's called as vectors. Whatever information we already have, whether it is text or image or video or audio file, we can convert them into vectors and do a search after converting them into vectors based on the distance metrics. These are some of the famous distance metrics available within vector databases. Cosine distance. In this case, if you actually see, if there are two vectors A and B, and the cosine distance actually is proportional to the angle between the two vectors. So more closer they are, the lesser the angle between the two, the greater the similarity. The equivalent distance is actually represents the physical distance between the 2 points. Okay, that is the number of steps that we take to reach vector 2 from vector 1. The Manhattan distance is something similar to the physical distance, but rather than taking the direct distance between the 2 points, right? It takes the number of steps that has to be taken exactly along the two axes, right? Namely the x and y. The dot product actually is something similar to the cosine distance, but if you see actually, it represents the physical distance between the two vectors. Unlike the Euclidean and Manhattan or the cosine distance, it actually measures the least distance between the two points. So, if you look at the diagram of the below the dot product, right, we will be able to understand what actually it means. So, vector databases, right, help us to store the vectors, and later on, right, when we supply a vector, it can do a comparison between the existing vectors on the basis of cosine distance or dot product or Manhattan distance or Euclidean distance and return the results to us. Weaviate is one such open source vector database, and they also provide us with a trial version for 2 weeks so that we can host the cloud edition and do our experiments. So I just logged into the Weaviate cloud, and these are the clusters. You can, if you want, you can go and click on create cluster to create a new cluster. And I have already created a cluster. So I have given a name Weaviate intro, and you can go and look at the results of this cluster here. This will be the REST endpoint, which we will be using in our Python program to connect to the Weaviate client. And you can click here to get the keys. And this is what you will see in our first step. After installing the necessary libraries, right, I simply create instance to the Weaviate cluster. Here I have to specify the URL that you see here, and the API key you obtain by clicking on the API keys, right? You have to put it here, and then right you can run the client dot list underscore ready and see the results. For example, if I run this here, so which means that right now I have connected to the client now. Now, as a first step, right, this is what I'm going to do. And I'm going to the Weaviate dashboard again and see what are the collections that are available. There are two collections available, document search and unnamed search. I'm going to delete the document search now. And delete it. Yeah, now I have only one collection called name search. I'll go and create the document search again. So first thing is, right, I have to supply with the name of the collection that I am going to give it as a document search, and it is going to have a property called a doc text. Okay, so it is like a collection is like a table in relational data model, and the properties like a column in relational data model, and these properties of type varchar, that is text. Okay. So now here, right, along with when you're specifying new collection in Weaviate, you know, to not only specify the name of the collection and what are the various attributes or the properties you have, you should also specify how you would actually supply a vector to represent every row, every new addition to the vector this collection. Okay. Now in this case, right, I'm not going to I'm going to provide my own vectors. Okay, I'm not going to use any third-party APIs. I'm going to supply my own vectors. So I'm setting the vector configuration folder. There is also another configuration option wherein I can specify the index. I'm not going to use it now. Now for now, right, I'm just going to create a collection called the document search, and it will have a property called doc text. It is of data type text, and it doesn't have a vectorization, which means that every time I supply a value, I should also supply a value for the vector. Okay. So now I run this to generate the new collection called a document search. So it has created a new collection. Now let's go and refer here. If you refresh the collections, now if you see there is a document search, and I can click on this edit, you will be able to see the properties. This is a doc text property, and it is of data type text. Okay. So I am not going to make any change. I'm going to cancel. Now there's the next step, right? I have a list of values right now. I have the list of the skills of various employees. Sequence over Oracle Power BI, sequence over Power BI Tableau, and so many things. I would like to take these values and insert these values into the collection that we have created, which is what we call as document search. So here first I'm going to supply the values here, documents. Then I'm going to create an instance of the document search. So I simply call client.collections.get and specify the name of the collection, so that right I can represent document search to complement the document search in the Weaviate the collection. Okay. And this method, right, helps me to import the data in batch, multiple records together. So with document search.batch.dynamic as batch, right, I will be able to import multiple records into the collection in one. So now what I'm going to do is I'm going to read row by row, the various values in the documents, and I'm going to create something called as properties doc text, because remember in the document search, right, we have a property called doc text. So we are only specifying saying that, right, for this property doc text DOC, this will be the value. Okay, that's the first step we are doing. Now since I'm going to use NLP to generate the vector, right, I'm going to call the NLP function and supply the value doc, whatever value that you're going to get, sequence over Power BI or sequence over Power BI Tableau as an input. Then, right, the NLP doc will give me a vector. I'm going to convert the vector as a list. Then I'm going to add. So in this case, right, I'm going to add 5 rows, sequence over Oracle Power BI and another 4 rows. So let me go on and add these 4 rows. I run this. Okay. Now I can go and see what are the values that are available here. So for this, right, I simply specify the client.collections.get to document search as a collection, and simply call the standard procedure, standard routine to print the various values that are stored here. So let us go and see what are the values that are stored here. Yeah, first is sequence of Power BI Tableau, and that's followed by the vector representation. Next is QQ Snowflake, Tableau QQ, Databricks as well effective, and sequence of Oracle Power BI. We also have seen right now how these values, right, are represented in vectors using NLP. Okay. As a next step, right, now I'm going to search for this time. For example, I'm going to search for Databricks inside this document search. Okay, so this is what I'm going to do. Simply, as earlier, I'll be calling this client.collections.get with the collection name, and then, right, once I get the collection, now I'm going to store the collection something called as a local variable skill set. I can use the skill set query that near vector method, which means that, right, I'm going to give you a vector, and any vector which is closer to this vector, right, return me those vectors. That's what we are doing in this code. So I'm going to take this query text Databricks, and I'm going to call the NLP method with this particular query text, and the result doc vector, right, I'm going to convert into a list, and then I'm simply specifying near vector equal to query underscore vector. Okay, so use this document search collection of vectors, and any vector which is actually closer to this vector that I specified here, and return with the results. So now let us go and see how the results look like. So I'm trying to get the response from here, from the response.objects, and I'm printing the properties text. I'm also printing the property, just like we saw earlier, right? Vector distance metrics, right? Whatever the vector distance metrics computed within the query vector as well as the vector that are stored already in the database, right? Those values return both is what I'm saying. So when I run this, yeah, the search looks good, right? Because the Databricks is ranked third. However, little weird is that right now we have click view and tab view coming up. This is something we have to fix. We will fix it a little later, but we can proceed to the next step. Okay, so in the next, the other method of querying is actually Weaviate provides is the tokenizer. You can go and read a lot more detail about the tokenizer. Tokenizer is essentially you have a string and you split it into multiple tokens based on different approaches. One is the word-based approach where you will split everything, every individual word as a separate token, and lowercase, convert everything into lowercase, and then right now separate split the text into various parts using the white spaces. And you also have a method to use the field tokenization, okay, wherein you will take the entire string as a single entity. So field tokenizer. So now we will use the tokenizer method to search. Now the same document search as collection, and I would like to search for a string database. Okay, this is standard code, and let us run this to see how fast we can retrieve the results. Yeah. Dark text. You have an entry which contains database as well. So far, so good. Only thing is, right, we were able to do two approaches. One is the vector-based near vector approach. Another is the tokenizer approach. The tokenizer approach works very well. However, in vector-based approach, right, it gave the results, but right, we saw that right database was not listed on top. We need to fix that, but before we go on, let us see how we can insert a huge volume of records into Weaviate and retrieve the results. So for this, right, I'm going to use the vector library. I'm going to create a name search as a new collection with the an attribute called the person. Okay. And if you see actually here also when I'm specifying the class, I'm specifying that right vectorizer as none, which means that right I'm going to supply my own values of vector. And right for the method of indexing, I'm going to use the vector index.hnsw. The HNSW is method of indexing which is similar to skip list in the conventional data structure. You see, right, in skip list, the lowest level will have all the values, and at the highest level, right now we'll have some minimum number of values. To start at the highest level, see which value is closer to the value you're looking for, and then we will drill down, go up or down depending on the value is closer to the one you're looking for. So while this requires some duplication and little may not be suitable for smaller data sets, this works very well. Skip list works very well with huge volume of data, so that right now the return result can be retrieved very fast. The same case with HNSW also. The HNSW also works in a similar fashion. You will have various levels, and the lowest level has all the data. At the highest level, right now, you will be able to figure out whether the data exists that you're looking for is closer up to the vectors in that particular level. So that right now you are able to skip a lot of unwanted elements and proceed forward to the level where more likely you will find the values that are closer to the one you are searching for. Okay, so that's a method of indexing I'm going to use. In fact, I can put create the collection name search here. Okay, so next thing I'm going to do is I'm going to use the faker library, and here, right, using the faker library, I'm going to generate a fake name. Okay, and I'm going to insert around 100,000 records into the Weaviate, and it took around nearly 10 minutes for me to import all of the same. It's like earlier, right? I'm also creating the properties mainly because if you see the name search, if you go and edit, right, name search is a collection name, and it has a property called the person name, and that's what I have mentioned here, person name, and the person name should have the value fake name. Fake name is what we are generating here, and then right, I'm calling the NLP function the fake name, and the result vector I'm picking up and converting that into a list. Okay, and then I will be inserting the values into the Weaviate using the batch process. Okay. So it takes around nearly 10 minutes to do the insert, and this is one of the names. I have just picked the first name so that right now we can use for the purpose of searching. And I go to the search here. Okay, pretty much the same stuff using the near vector method, and we are here also we are using the same NLP query method. Okay, So static ready, we are able to find, okay, within less than 0.6 seconds, all the values matches that of course one. Okay, so VBA works very well with the HNS we are able to search among a huge volume of collection really fast. Okay, so now remember, right, earlier we had an issue. The database when we searched, right, the database came there. So now we have to go and see how we can fix it. And for this, right, instead of using NLP, I'm going to use another library called the fast text. Okay, the faster text now is a NLP library which will help us to generate vectors for a given text. So now what I'm going to do is I'm going to simply pick up these words, SQL Server, Oracle, Power BI, and I'm going to tokenize them, which means that SQL Server will be separate, Oracle will be separate, Power BI will be separate, and then right I'm going to create a new model. So this would be this is how the end result will look like. SQL Server, Oracle, Power BI, all keywords are split separate, this split separate. Okay, then right, I'm going to use this f-text. F-text as the model that we have created just now. I'm going to create the f-text as the model for me based on which I will be creating the vector. So now essentially the process remains the same. However, the method by which we are generating the vectors for a given text, right, is changed. Earlier we were using NLP library. Now we are using faster text library. We can go through the code later to see the details between the difference between the two. Okay. So now let me go and go to the collections. I'll delete the document search collection. Yeah, so collection is new now. I come back here. Yeah, create the collection again. Yeah, the collection is created. Now we have to add these values. Okay, now remember, unlike earlier, we are using f-text to generate the vectors. So let me go and run this here. Yeah, if you see, these are the values that are added. You have the very skill set and also the vector representation of this same skill set. Now let us see if there is any difference quantitatively, qualitatively. Okay. Now this is the string I'm going to search. I'm going to search for SQL Server table now. Okay, let's, since we want to do a comparison, we'll first search for Databricks. I search for Databricks. Yeah, now Databricks comes first, mainly because faster text, right? Now it is essentially the same computation process. However, faster text produces better vector embeddings. Okay, so when you are playing around, don't feel shy to play around with your data to decide what is the best vector method to generate the vectors to suit your use case. And accordingly, right, the vector databases can help. So the suitability of vector embedding model, right, as far as your use case is concerned, is a product specific one. So you need to be careful as far as choosing the vector method approach is new. Okay, now we'll go and try again. Now we have the, let's search for SQL Server. Okay, I search for Tableau and SQL Server. So Tableau and SQL Server. Now run this. Yeah, SQL Server Tableau comes first. Understandable mainly because it contains at least both the keywords SQL Server and Tableau. Next one we have Tableau. It doesn't have SQL Server, but it has Tableau. So understandable it comes second. And the next one, right, you have SQL Server, but not Tableau. Again, it will match because it contains one of the keywords. So it looks good. We'll go and search for something else now. Maybe Snowflake. Okay. Yeah. So now if you see actually, yeah, QQ Snowflake comes on top. Okay. And yeah, if you see, then comes the database as well, reflecting SQL Server Power BI, Tableau QQ, SQL Server Power BI Tableau. Okay. So now if you see actually, right, the results are better than how it was when you used the NLP for generating vectors earlier. So this code is available and the URL is also given along with the YouTube video. You can go through the code and play around. You can also get the Weaviate 14 days subscription and play around this code to figure out how vector databases work and what should be the appropriate method of generating the test for your use case. Thanks for watching. Appreciate it. Take care. Bye for now.